I hope all of you are doing good. Let's start today's chapter, pairs of lines and transversals. In this chapter, we shall study about a pair of lines, a transversal, angles. A transversal makes with a pair of lines and relations between angles made by a transversal with two parallel lines. We shall assume that all lines we consider are in the same plane. Okay. Transversal. Okay, what is transversal? A line intersecting two or more lines in a plane at different points is called a transversal to the given line. See, these two lines are intersected by a line, so this is called a transversal line. Okay, so consider two lines L and M in the same plane. Let a line N lying in the same plane intersect the same lines L and M at distinct points A, B as shown in the figure. Then N is the transversal to the lines L and M. Now consider the following figures. See, this one and this one. In figure 1, L does not intersect two lines M and N at two distinct points, as you can see here. Okay, so L is not a transversal. In figure 2, M does not intersect O and L. See, it doesn't intersect O and L at distinct points, but intersect this line L and M. As you can see, this is L, this is N. L, this is L, this is N, and this is the line M which is intersecting these two lines. Okay, so M is not transversal to O and L, but M is transversal to L and N. Similarly, O is transversal to L and N. Okay, means this line O is transversal to L and N. Okay, but not to M and N. Right? Next, parallel lines. Lines which belong to same plane and do not intersect are called parallel lines. Note, through one point not on the given line, there is only one line that can be drawn which is parallel to the given line. Okay. Next, angles made by transversal with exterior angles. The angles whose arms do not include the line segment AB are called exterior angles. Angles 1, 2, 7 and 8 are exterior angles. Okay. Interior angles. The angles in the region of L and M with line segment AB are called interior angles. Okay, in the figure, angles 3, 4, 5 and 6, this is 5, this is 6, are called interior angles. Number 2, corresponding angles. Pair of angles which lie on the same side of the transversal and lie above the lines with the transversal or below the lines with the transversal but are not adjacent. In the above figure, we get 4 pairs of corresponding angles. They are angle 1 and 5. See, angle 1 and 5. Then angle 2 and 6, 2 and 6. Angle 3 and 7, 3 and 7. And angle 4 and 8, angle 4 and 8. These are corresponding angles. Okay. Number 2, alternate angles. Pair of angles which do not lie on the same side of the transversal. Line interior region of L and M with the transversal or line exterior region of L and M with the transversal but are not adjacent. They are called alternate angles. Okay. Next, alternate interior angles. A pair of angles in which one arm of each of the angle is on opposite sides of the transversal and whose arms include a segment AB as shown in the figure is called a pair of alternate interior angles. In the figure, angle 3, angle 5, angle 4 and angle 5, these form the two pairs of alternate interior angles. Next, alternate exterior angles. A pair of angles in which one arm of each of the angles is on opposite sides of the transversal and whose other arms are directed in opposite sense and do not include segment. AB is called a pair of alternate exterior angle. In the figure, angle 2 and angle 8, angle 1 and angle 7 are two pairs of alternate exterior angle. Okay. Next, properties of angles made by a transversal with two parallel lines. Activity 1. Let us draw a line L parallel to M in the same plane. Let a transversal P cut these parallel lines at distinct points as shown in the figure. We mark the angles formed from 1 to 8. With the help of a protractor, we measure the magnitude of all angles formed. Okay. With the help of what? Protractor, right? Next. So, we will find that the following facts, that angle 1 is equals to angle 5, angle 2 is equals to angle 6, angle 4 is equals to angle 5 and angle 3 is equals to angle 7. Thus, we observe that if two parallel lines are intersected by a transversal line, then the angles of each pair of corresponding angles so formed are equal. Okay. Number 2, angle 2 is equals to angle 8. and angle 4 is equals to angle 6. Thus, we find that if two parallel lines are intersected by a transversal, then the angles of each pair of alternate interior angles are equal. Number 3, similarly, if we measure alternate exterior angle, that is angle 2, angle 8, angle 1 and angle 7, we get angle 2 is equals to angle 8 and angle 1 is equals to angle 7. Alternate exterior angles made by transversal with parallel lines are equal. And number 4, angle 4 plus angle 5 is equals to 180 and angle 3 plus angle 6 is equals to 180. Thus, we see that if two parallel lines are intersected by a transversal, then the sum of the interior angles on the same side of the transversal are supplementary. Thus, we can observe the following properties of angles formed by a transversal with two parallel lines. Number 1, the angles of each pair of corresponding angles are equal. Number 2, the angles of each pair of alternate interior angles are equal. Number 3, the pair of alternate exterior angles are equal. And number 4, the sum of the interior angles on the same side of the transversal is 180. Remember these points. Okay. Activity 2. Let us draw two non-parallel lines. See, these are two non-parallel lines P and Q. Let them be cut by a transversal R at two distinct points. We number the angles so formed 1 to 8. We measure all the angles. What do we observe? We observe that none of the properties which are true for parallel lines are true for non-parallel lines. From the measurement, we conclude that if two non-parallel lines are intersected by a transversal, then pair of corresponding angles are not equal. Number 2, pairs of alternate interior angles are not equal. And number 3, sum of the interior angles on the same side of the transversal is not 180. Okay, this happened in case of non-parallel lines. So note, if corresponding angles are equal, the respective lines are parallel. Number 2, if alternate angles are equal, the respective lines are parallel. Number 3, if interior angles on the same side of transversal are supplementary, the respective lines are parallel. Okay, let's do example 1. In the figure, P and Q are parallel lines, right? And R is a transversal. And angle 3 is given, which is 60 degree. Find all the angles. Okay, so what is given? Angle 3 is equals to 60 degree. Now, angle 3, as you can see, angle 3 and angle 7, these are corresponding angles. So, angle 7 is also 60 degree. Okay, now move on to next. Angle 3 and angle 2. See, 3 and 2, these are forming linear pair. Angle 3 plus angle 2 is equals to 180 because they are forming linear pair. So, angle 3 is 60 degree. We have to find angle 2. Okay, and angle 2 is equals to 180 degree minus 60 degree. That is 120 degree. Okay, now we know angle 7 is 60 degree. Angle 3 we already know 60 degree. Angle 2 is 120 degree. Okay, now next. Angle 2, if you look carefully, angle 2 and angle 6 are corresponding angles. So, angle 6 is also 120 degree. Okay. Now, what? Angle 3 and angle 5 are alternate interior angles. Okay. Angle 3 and angle 5. Okay. That means angle 3 is 60 degree. That means angle 5 is also 60 degree. Okay. Angle 3 is equals to angle 3 is equals to angle 5 is equals to 60 degree. Reason, alternate interior angles. Okay. Now, we know that angle 5 is equals to 60 degree. Next, angle 3 and angle 8 are interior angles on the same side of the transversal. Okay. So, angle 3 plus angle 8 is equals to 180 degree and angle 8 is equals to 180 degree minus angle 3 and angle 3 we know that is 120 degree. So, angle 8 is equals to 60 degree. Okay. Now, angle 8 and angle 4, these are corresponding angles. So, angle 4 is equals to angle 8 is equals to 60 degree. Reason, corresponding angles. Right. Exercise 17.1. In the adjoining figure, a transversal R cuts two parallel lines P and Q at 2 points A and B respectively. If angle 1 is 50 degree, find all other angles. Okay. This question is similar to this example. Okay. similar to example 1, right? So let's do it. Angle 1 is given 50 degree. Angle 4 and angle 1 are forming linear pair, 180 degree. Okay. Angle 4 is equals to 180 degree minus angle 1. Angle 4 is equals to 180 degree minus 50. That is angle 4 is equals to 130 degree. Okay. Angle 4 is 130 degree. Angle 1 is 50 degree. And see, angle 1 and angle 5. These are corresponding angles. So, angle 1 is equals to angle 5 is equals to 50 degree. Okay. Angle 5 is also 50 degree. Okay. Now, you can easily find out other angles also. Okay. Learning outcomes. Number 1, a line that intersects 2 or more given lines in a plane at different points is called a transversal to the given lines. 2, if a transversal cut 2 parallel lines, then number 1, alternate angles are equal, corresponding angles are equal, and the sum of the interior opposite angles on the same side of the transversal is 180 degree. 3, if a transversal cuts 2 lines such that any of the following condition is satisfied. Number 1, a pair of alternate angles are equal. Number 2, a pair of corresponding angles are equal. Number 3, the sum of interior opposite angles on the same side of the transversal is 180 degree. Then the given lines are parallel to each other. Number 4, to a point not on a line given, one and only one line parallel to the given line can be drawn. Students, I hope you have understood this chapter. Now you will do practice of the remaining question of the exercise.